Remember, right, updating your study sheet. Very important. You never know when you get an AC. You never know. But chances are, right, you'll get one 3 to 4 times a week. So given the regular polygon to the right, so this is actually an important word, regular, right? All angles are the same. All interior angles are the same. All exterior angles are the same. And so forth, right? All side lengths measure the same. You notice that we're focusing on angles only, right? I could start throwing in sides, but then we need trigonometry and we haven't covered that yet. So down the road. The sum of all interior angles, that's what you want. So sum of, how many sides does this have? 11, I counted, right? So you start somewhere, make a check mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we established that. So an 11-sided shape is n minus 2 times 180. And that's 9 times 180, which is 1620 degrees. Make sure units are there. If you don't have units, half a mark off just once today, okay? And you'll still make a note saying that units are off, but there you go. The measure of each interior angle. You know what? I allow you to do this. Technically, you can just take the 1620 and divide it by 11, right? You're splitting that sum equally among 11 angles. And so that gives you 147.27 degrees. 1 mark for that. And obviously, if you got the top wrong, I see you using that number here, you technically wouldn't lose marks here because you understand what needs to happen, okay? The measure of each exterior angle, show 2 methods. So the first method would just be exterior angle of 11-sided would be 360 divided by 11, and that is 3273. Or exterior angle is 180 minus that interior angle up here, 147.27, and the exterior angle is still 3273. So if you used one of the methods, that's 1 mark already. So 1, and then for the other method that you're using, another half, right? That's why I'm giving you a mark and a half there. Label 1 interior, 1 exterior, and 1 central angle using IEC. So if you want to do the central, right, you find the center, and you do something like this, and then clearly say that is the central angle. That is one of the central angles, right? There are 11, by the way, 11 central angles. Interior, you go to any corner, you do one of these. That's the interior. And why not just right beside it have this as your exterior there, right? So I tell you what exterior angle is not, because I have this all the time. Some students go to the corner and just go out like that. It's not an exterior angle. That is, you can name it because you made it, right? But it's not an exterior angle. This is an exterior. So you have to kind of pick a side and just travel past it. So that's your exterior angle, right? So there's 11 of them. And they always add up to 360, by the way. The exterior angles do, okay? So that's it. So you get a half mark for each correct labeled angle up here. So if you got it right, just go check. No minuses. Keep going. A regular polygon has interior angles of, right, they each measure that, determine the number of sides. I don't know about you, but I'm going to use this method. The exterior angle, therefore, would be 180 minus 172.5. So that is 7.5 degrees, right? And then I'll just say that 7.5 degrees is equal to 360 divided by n. Put a 1 under here if you'd like. So it's multiply, divide. So that's 360 times 1 divided by 7.5, sorry. And n is equal to 48 sides. If you just completely guessed it and you're not showing any work, you don't get any marks. The point is to use algebra here. Anybody do it the other way? Probably. I have a feeling that some of you might have. If you get 48, you get full marks. If if you showed me the work. Let me see if I can do this somewhat. 172.5 is equal to n minus 2 times 180 over n, right? So the first step would be multiplying both sides by n. That gives you 172.5 n. And here it's 180 n minus 360, right? I already distribute that. You bring the 180 n over, and you leave the negative 360 there. This gives you negative 7.5 n is equal to negative 360, and you'll see that it ends up being the same. So n is equal to 48. Okay, so regardless of how you do it, 2 marks for that. Next, does it say only once? Yeah, it does say to only use every explanation one, and it kind of design it that way. So let's see here. I'm going to focus on what touches the numbers. So x is touching 32 basically. So I'm just going to say vertically opposite angles are congruent. That's number 1 for me. That's where I started. Please tell me that. So that's 32 here. And you can use the fact that x and y, did you notice that? What do we call those? Because this one is parallel to that one, right? These are parallel. So if I focus on this transversal, these are corresponding. Same side of the transversal, one is inside, one is outside, right? So y is corresponding, so that would be 32 degrees. Anybody use alternate interior? Yeah, fine. Yeah, it's all connected. So what am I doing here? Corresponding. Corresponding angles are congruent. Or alternate interior angles are congruent. It's okay. Then a z. I'm going to do z next because if this is 32, I have a triangle here. So 180 minus 32 minus 123, and that is 25 degrees. And I use sum of triangles equal to 180. Okay. Got it? So each one would be 1 mark if you have the right angle and the right explanation. Today I'm going to close my eyes if you used one more than once. Not a big deal today because it's still correct. Okay. I just want you to have a big view, not using the same thing over and over. M, you could use a straight angle here, right? Because if you focus on this line here, these two angles are along a straight line. So 180 minus 32, that would be 148. And I use straight angle. That's the last one. Anybody use something else there? I'm actually curious to see. You can't do anything with 123 and M, right? You can't. Because these two lines are not parallel, right? This transversal does connect them, but these two lines are not parallel. So yes, they are corresponding, but no, they're not congruent. Okay, you can't say that there's 123 there. So 4 mark. Oh, I give you 8. I see how this works. So basically 1 for each, right? So if you got it all right, if you justify it and it's right, you get 8 out of 8 there. So what are we at on this page here? 15, right? 8 and 2, that's 10, 13, 14, 15. So if you want to already subtotal, this page is out of 15. If you had all missed the degree symbol, you lose half a mark on this page. I don't know. I just don't find it. It doesn't make sense. Like I know some teachers will probably take off like half a mark for every single one. It's beside the point, right? I want to know how much you know, not how good you are at remembering to put a sign there. Work out the size of angle X, and I saw a lot of you stomped on this one, and I don't blame you because sometimes it's just how it is. We draw blank, right? But you see these ones here, these marks. What kind of triangle is that? Equilateral, right? which we then know that these all measure 60, right? And around this point right here, any point ever, if you turn completely around, it's 360, right? So I'm going to introduce a variable here. I'm going to call this y, this angle right here. Angle y is 360. That's a full circle minus the 60 that I just found, okay, minus the 250 out here. Okay, so that would be 50, right? 50 degrees for that. I would give you a full mark for that step right there. If you come up with that angle, whatever you called it, even if you show the work somewhere close by and say, hey, that's 50, you're good to go. And then I need another highlighter here. I see that this triangle here is an isosceles triangle. So if this is 50, this is 50 also. Got it? Because the angles across those congruent sides are 50. So I will say that angle X is going to be 180 minus 2 times 50. So it's 180 minus 100. So angle X is 80. Another mark for that. And oops, sorry, it's kind of crooked there. You can see, right, sum of triangles equal to 180 here. It's isosceles, right? You don't have to, but I'm using that property. I don't know what to say here, to be honest. Like full circle is 360 or something like that. If you show me the work, I'm okay with that. So remember, markings, polygons, and markings are your friend because you can figure stuff out just by looking at that. Okay, so 2 marks there. PQ and RS are parallel lines. So let's make a note of that, right? Like this line is parallel to that line right there. The markings are on there as well. They're kind of hard to see, but they are there. And let's see, angle X. How could we figure out angle X? I might start with something that's touching a number. And I see that Y is a good start, right? Y would be 60 degrees, vertically opposite. What happened there? Vertically opposite angles are congruent. That's my start there. I start with that one. Let's write it in, shall we? Right there, boom. Z is straight angle. Either you look at it this way or this way, it doesn't matter. So I'm going to go 180 minus 60, that's 120. So I use straight angle is equal to 180. So that's 120. Come on, there we go. 120, that's my second to go. And here, watch this, this is important. You can either say, like if this is 120, then I know that this angle here, this whole thing, is alternate interior to this whole thing there, right? It's a little busy here, but this whole thing, if you look at this as being a transversal, it connects those 2 parallel lines. There you go, right? So if this is 120, then these 2 angles that are formed here should add up to 120 as well. Does that make sense? I hope. So I'm just going to go 120 minus 38. Okay, and that is 82 degrees. I'm using alternate interior angles are congruent, and I'll show you a different way. There's also another way of doing that. I'll just put 82 there. What are these 2 angles here? Like this whole thing here and this whole thing here, these would be consecutive interior, right? They add up to 180. So you can go 180 minus 60 minus 38. You still get the same answer. You still get 82. So if you did that, that's fine. You get full marks there. 6 out of 6. So 1 for the correct answer, 1 for the correct explanation. So some of these are tougher, right? But kind of want to get you out of your comfort zone and also encourage you to do the work, right? At home, update your study sheets, so stuff like that. So we have a volume of a sphere, and a new sphere is created with a different volume. You can clearly tell that this is a reduction. K should be less than 1, less than 100%, no matter what. Determine the scale factor. If it's volumes that you're comparing, then you go volume of new, right, over volume of the original. Sorry, did I say volume, right? Should be 3. Should be 3. So yeah, the unit should cancel out just like that. So K would be cube root of that. So I'm already gonna just divide that. Okay, 375 divided by 732.42. So a cube root of 0.51. Keep going. And now I'm gonna cube root math, fourth option, of my previous answer, and it's 0.8. Right? It's a reduction. It's a 20% reduction of the original. Remember that? Because you only have 80% left, so it's a 20% reduction. Next, miles per hour to kilometers per hour. So 20 miles in 1 hour. I have that 1 mile is 1.6093 kilometers. And I have that 1 hour. Oh, that's all, right? We're done. Sorry. That's all I need to do there. And no equal signs here, okay? You're multiplying. This is not a proportion. So this is 32.19 kilometers per hour. And then 35 gallons per minute. 35 gallons in 1 minute would be 1 gallon has 3.79 liters, and that 1 hour has 60 minutes, because you want to cancel out the minutes here, the gallons there, and you're left with 79.38 liters per hour. This one is worth 2. This one is worth 1. If you have one of them wrong, like what I mean is if the rate isn't where it's supposed to be, go -1 right away. Okay. Are you disagreeing?
Yeah. It should be 7959.
7959? Everybody's nodding. What happened there, right? What happened? Oops. You're right. 7959 it is. There we go. Minus half for Mr. Dirksen for getting the wrong answer. Okay, so 2 and 3, that's 5, and 6 is 11, and 2 is 13. The backside is worth 13. And so 13 and 15, that's 28. Name and last name. Okay, you will get this one back. So if you make corrections, as long as you make corrections using a pen, so that you're not saying I did this.